Yeah, so welcome again from my side as well. And we will talk about, as Moritz said, I've studied way back when also at TUM. And what we try to bring here is a little bit of experience so that, as I said also in the video, what I would have liked the older version of Saksham to learn a little from the industry when I was in those benches as you are sitting right now. So the use case right now is a data platform, which a team of colleagues together with whom I helped build as well, and we were using cloud. And I take through the journey of when I was building things for the cloud the first time, and this data platform, which was actually also showcased in a keynote by Amazon Web Services. So let's go ahead. So I am originally from Nepal, so namaste. And I'm a computer scientist by training. So I studied at TUM, did my master's thesis also at Carnegie Mellon, was doing CDTM as well way back when. Right now I'm working as a consultant for around 8 years, doing stuff with cloud. And I help organization move to cloud, and not only platforms, but also the organization, because it has so many implications on tech, how the skill sets are for people, how the recruitment strategy goes for companies as well. What does it mean for SMEs, for example, to move to cloud? What does it mean for big corporations to move to cloud? So that's so many dimensions, and I help companies navigate through this jungle, let's say right now. But at heart, I am actually super passionate about autonomous driving, which I try to put on a little bit of like energy whenever I get time from my little 5-year-old who keeps me busy also. And and I've been working with cloud since quite some time now. This was when Microsoft was building their data centers for the first time in US. And Azure did not have that name yet. So that's where we were already collaborating. I have that use case in a bit. But so been doing cloud for quite some time. All right, so what I would like to do now, it's a little bit difficult to do with the audience and that are joining online, but let's try to do it in the stage. So I want to know what the level is in the room a little, and so that I can just, let's try to have it a little bit interactive. Let's see how that goes in terms of time, but I'd like to know you a little. So please keep your hands raised when this applies to you. So I'll read so that you know that Amazon maintains their own data center. The company that bumped up the Prime membership by €1 yesterday, right? It has its own data center as well. You know that, right? Okay, everyone. And you have used a public cloud provider. So not only LRZ, but actually you've done something with GCP, Amazon or so. Okay, nice. That's all through them. So you have deployed your code. So not clicking around, you've deployed something with code onto these cloud providers. Nice. So the hands are still up. So you've deployed production workloads to the crowd so that when your service was down, money was lost. Okay, nice. Some hands raised. That's fantastic. So you've migrated production workload to the cloud without downtime. Okay. So some people still have their hands raised. That's nice. Okay. So you have encountered a technical limitation from a cloud offering that you had to do it yourself. Okay. Nice. Still some hands raised. That's nice. And you've faced a real, not hypothetical, limitation of cloud and serverless framework and had to move back. So serverless was not enough for you. Okay. We have at least one hand raised, but great. Okay, so let's try to have it interactive. So based on the hands that you raised, I think the levels will be different, but I think let's try it out to have interactive. And you have contributed to the development of the cloud infrastructure under the hood for a cloud provider. So actually you have worked with a cloud provider. Okay, we have at least one person. Okay, great. So I think we'll kind of oscillate between this. Hopefully not so much at the top, but we'll oscillate a little and try to go under the hood. So what I have planned for today would be, so just to give you an overview of what cloud providers are out there, just to give you a little bit of flavor. From the hands raised, I think that would be quite quick. Then going back to some foundations, architecture, patterns, and then we dive into the business case for the data platform. So what we were building, or what Saksham was building together with his Netlight colleagues. And then we try to tear it apart piece by piece and try to give you the reasoning that we were, that were helping us make decisions at that time. And then a run through of lessons learned. I try to list them, but then the lessons learned would also be scattered throughout the lecture. And then and we will have ample time for questions and discussion. So if some burning topics come and then you are like, no, Saksham, just explain me, I don't get it. Raise your hand and we take it, but then we'll see. And we have ample time to talk with Miki as well, with me, and go deeper into any of the topics that you have, let's say you need more explanations on. All right, so far so good, I suppose. Okay, so major cloud providers. These are the big names. So Amazon Web Service, Microsoft Azure, Alibaba have their own. Google is also a big name. And a report from Gartner says that Amazon is actually growing more and more. And that's also the rationale for why I try to use Amazon as a cloud provider, which I use for all of the examples here. But the concepts should generalize to all of the platforms here. So Microsoft Azure, they have different philosophy, they have different culture, they have different tooling, but the idea is essentially the same in terms of allowing companies not focus on undifferentiated heavy lifting, which is what these companies would do, so that the companies using the cloud can focus on their business. Right? That's the more or less the big idea. And the focus is the maturity of developer within the organization is different, and there are different dimensions on choosing the cloud provider of choice. But if we abstract away from all of these cloud providers, there are lots of concepts with which you can say, you just make a pick, anyone works, you are on the cloud, and you go forward, right? So that was also, so we ended up using Amazon back then because it was already there. But I could imagine all the things that we have built would have been the same with Azure or GCP as well. Alibaba Cloud I have not worked with, so I can't say much about that. Okay, so going back to the fundamentals, there were a lot of people probably about these things, but I still want to reiterate them, right? So what does it mean to go to cloud first? And there's a generic thing that everyone probably brings up when talking about cloud. It's like you make a pizza. That's your application. That's your web application, which is serving millions of users or whatnot. So traditionally, on-premises service, what they do is you have your goat giving you mozzarella cheese, you have your farm, you have a Riviera in Italy, you build everything homemade. It's handcrafted, it's perfect in a certain way. So that would be on-premise, right? And we're not there in terms of cloud. The other side would be you are still serving pizza to people, but that's a pizza as a service now. So the ingredients, the raw materials, you go to a supermarket, so you don't have the goat to give you the cheese, you don't have the wheat field to give you the wheat, you don't have meals and so on. So you go to the grocery store, you buy pizza dough, you buy tomato sauce, you buy toppings, you buy cheese, but you have a decent kitchen, so you can cook your own pizza, right? So you have infrastructure as a service in the sense you are provided these bare metal service and you build things on top, right? Going forward, you could say, no, I don't have a kitchen, but I can decorate the table because, let's say I have it for my wedding, and then I need a certain type of decoration, so I take in the decoration, pizza will be served, drinks I want to serve because, I don't know, I like this champagne or whatnot, right? But then you outsource a lot of things to an external company. You go all in terms of you just show up, right? It's your wedding or so, and you just show up, and there's a catering company which does the table, and does the drink, and then you just show up, you have ready to go pizza prepared, and you can enjoy your pizza. So it depends on the level of control that you want to give to other company, which that will define at which level your infrastructure in-house should be able to serve. And we would be focusing a little bit on, right here, somewhere in between these two. And even sometimes at software as a service. So Gmail, imagine Gmail, this would be, let's say we building up LRZ. Here would be like IBM and Hetzner, these companies that provide like bare metal servers. And usually the names that I described would be mostly here. Okay. No questions still now. Another concept is like pets versus cattle. So when you didn't have so many servers, or you did have servers, but you're doing a lot of things on premise, you have this concept like you treat your servers. They have names, they have characters, they have personality even, and then you treat them as pets and not as cattle, right? So you have like this server is like, this is a Windows machine. Every now and then, like 2 days, you need to reboot that machine. This is a Linux machine. I put my bash profiles there. You have to, do these many things, and then you can actually be productive. It's not scalable. So in cloud, what you have to do away is like it becomes just a machine. It has a number or a name, and that's it. And it can go on and off every now and then. So you can't be with this pet mindset. And way back when we were working, when I was working with a company, even the naming convention of computers, so we had Sun as a domain controller, and the name of the planets would be the main servers on the sites. So we had offices in Prague and Ipswich in UK, and they had like the names of the planets, and all the workstations would have to have name of a satellite, man-made or natural. Right, so I had my little my notebook was called Helios, and it had a personality. That's not how cloud could work. Right, you have essentially VMs with names. Now the names. How does a name look like? So the names have to have a sort of hierarchical structure. So if you look at what a name at AWS looks like, and GCP would be similar. Again, I'll keep repeating this less and less as we go through the slides, but Azure would be similar as well. But then you have a hierarchical naming scheme which identifies a specific resource in your data center, a specific service. So in this case, you have a partition like arn.aws, arn:/AWS. That's like, an AWS resource. Then you have a service. It's like EC2, Elastic Compute, as these are like VMs, right? And then you have EU Central 1, which is saying, of all the VMs around the world from Amazon data centers, it's Frankfurt data center. So you're narrowing down. Then you say, it's a multi-tenant setup, as you can imagine. You have different people having the same account in Amazon's data center in Frankfurt, and then you have a number identifying which user it is, right? So you narrow it down. Then you have an identifier for the resource. So it's like, in this case, an instance, which is So that's essentially pinpointing you to a specific VM in your data center. Again, pets. No pets, right? You can't have you could have, but you don't generally have this. So you have just an identifier. So a bucket would be similar. A database would be similar. Hierarchical, pinpoint to a specific instance. Then resource can be operated upon. It's quite a simple concept, right? So you can pinpoint to a resource. It's a hierarchical structure. So you could say everything in Frankfurt. Everything for my account. So a lot of things, these can be wildcarded upon as well. So it comes with a hierarchy. And they can be operated on. So there are like sets of actions that can happen on these resources. And the operations can be access controlled. Right? So you could say deny or allow on any operation on a resource. Then these operations can be associated with a policy document and can come to the user. So it's quite simple. So you want all of your users to be able to come and do everything with a VM. So you say star on the operations on the subtree of your hierarchy, and you say allow on those users, right? So there's another concept of roles, and this is also very important. So you can't scale it to users, but then you have to say, okay, these are operators of your web shop, and they can do certain things. These are the users of your web shop. These are the developers of your workshop, and based on that, you essentially say what they are allowed to and what they are not allowed to do. Right? So, but simple concept. Hierarchical naming structure, limited or a finite set of what operations can be done on them, and by a user assuming the role, that's audited, and by you operating on the resource, that's audited as well. Right? So very simple constructs, and with that, what you could imagine a setup being like, it's like you have let's say a technical user. Now, if a person can do something on the cloud resource, then a computer could also do that thing. And that now builds to a concept of, let's say, technical user. So something with a username and password is able to operate on, have an access control model around it, and spin up resource, steer down resources, and so on. Now, assumptions of roles and operations leave audit trail. Right? So every operations leave audit trail, and when you assume a role, that also leaves an audit trail. So everything is, like leaving an audit trail. Right? So this is going to be important. Like right now, I am working at an insurance company, and that's very important for them in terms of they need everything to have an audit trail, and that comes essentially for free. And another thing which is very important is that DevOps is crucial. Like, I guess everyone knows DevOps, so I guess I don't have to repeat what DevOps means. But essentially, what is very crucial is that we can't just have this model of developers shipping code and then handing over like in a formal procedure to like an ops team who is like Linux gurus and so on. That doesn't work. We have to bring production to the developers. That's why DevOps is super important, because what has been important is, like, for us was we were a team of 5 people, and we had to be the ops and we have to be the people developing as well. So DevOps was absolutely crucial for us. So things like CI/CD, automation, and infrastructure as code was very, very crucial for us. We couldn't have done without it. So CI/CD, continuous integration, continuous delivery. That means you need to have some sort of process which gives you confidence. So testing comes here, right? Clean code principles review process comes here. So you have to be able to be quick to deployment, that you don't have to think and define, okay, I'm going to have a new change. How do I take it to production? No, that has to be really nailed down from the beginning. So we were like Jenkins and GitHub Actions, GitLab Actions, that these are the kind of just an example, couple of examples in this domain. But essentially, when you write code, that has to go to production quite seamlessly. Infrastructure as code is also quite important. And there were a lot of hands raised. People using Terraform, CloudFormation, okay, CDK. Okay, cool. Some people at least. So the idea is actually quite simple. So you say, let's say you need 3 virtual machines for your web shop or website, right? And then you'll have one load balancer, 3 virtual machines. You don't go to the console and create these 3 machines. You just say 3 machines, 1 load balancer connected with them somehow. And there are 2 kind of major ways of doing it. One is declarative, where you say, I don't care how you create these 3 servers. I need these 3 servers with this base image and 1 load balancer connected to them. Or you say, that would be declarative. The other way would be imperative, where you say, I need a basic, let's say, Linux box with these kind of settings. And after this machine, please create the second one and then attach it to the load balancer, then create the third one and then attach it to the load balancer. So you describe a little bit on the steps needed to arrive to the end state. Right? But both of these approaches, I would put them on the infrastructure as code, where you say, what's the state of your cloud setup that you would want to have. And that's very important as well. And in terms of automation, kind of bringing these two together, it overlaps with everything. Very important topic. And if there's one thing that I would like an older version of Suction to have taken from this lecture, would be like automate everything religiously. And that's what we were doing as well. And when there was something that you could do with a click, please put it in code. Script it, whatever. But please put it in version control. And what also was very beneficial, and this is also kind of granted, not so much on the pizza, like your, really nice pizza world, but rather like pizza as a service world, is that it's very beneficial to abstract away to a programming language, and it's safe to assume in a lot of setups, like you can expect like Python or some high-level programming language is supported and out of the box installed in these machines, right? You set it up to that level, so you don't have to do lower-level scripting like at shell scripts and so on, because it comes with different challenges and it's not worth it, right? Okay, so now coming back and wrapping it all together in terms of like building blocks. So if you look at any cloud provider's offering and go to the web page and see, there's like thousands, maybe it's a lot, it's an exaggeration, but like hundreds for sure, of services out there that you could use, and then it's easy to be lost in like zoo of tools. But what we built up, like when I was working in 2008-ish with Azure, and this was way back when, that these were the services that were offered. Like if Azure would have a website then, there would be like 4 services. There's no database. There's no like funky stuff like with SageMaker, with like what have you these days. Even the relational databases were not there. And that's what we were supposed to be using to build a search and rescue application with satellite tracking. And we managed to actually save lives of 10 people, all using these 4 basic blocks. So my message here is like these building blocks are offered in all the cloud providers. And with this, if we could build it, you could do it as well. Right? So that's the lowest level that you could go to. And still, you don't have to have the Riviera in Italy to make your pizza. Right? So we were, for instance, using compute, blob storage, and queue together to build a transaction. We were essentially building write-ahead logs. And that's what these cloud providers have been doing. So that at a different abstraction level, depending on how much control you want to give, so you can get just an endpoint for a database, or you can say, no, I want to have like SSDs for my database. Right? So you can have on different abstraction level, different offerings, all the way to 4 or 5 components, which is where you have all the flexibility at hand, but also like bugs can come from you. Right? So it's possible. That's the message. And they are, again, built with the same building blocks that you have at your disposal as well. Okay. Right. So now building a data platform. So what is what we were building? So we were, as I said, a team of 4 engineers. We were building a platform, and then the idea is quite simple. So you have a CMS system, which is serving news articles to users who is reading that. That's the white arrow. And then you have, I need to point here. So let's see, right. So you have the content is digested by our platform. So a little bit of NLP, you can imagine what the article is about. Is it about politics? Is it about football? Then you have the user coming to the, to the website, and which also notifies the platform, okay, this user is reading about football. And then from these two sources, analytics is generated. Then you know, okay, this user read about football. And then the arrow 4 would be you give more articles about football, right? So recommender system would be number 4. So we essentially built this with like a handful of engineers, and we built a cloud platform. And I just want to show you quickly how that. What is the thing that we created? So this is when you go to a media website these days, you get this like approval, yes or no, and based on that, when you click yes, usually you have or until you click I reject, then these are not activated. But then otherwise, what happens is like it sends a HTTP GET request to a backend. It's a bunch of things, and if you kind of dissect it piece by piece, this is saying which browser you're using, which OS you're using, what's the size of the browser, and based on that, and also sometimes like also which article you are clicking on, and that's like standard way of tracking. And what it asks for is like usually it's a 1-by-1 pixel. So these are also called pixels. But what you get back by sending an HTTP request to your to the backend is just a 1-by-1 image that is downloaded by the browser, and oftentimes this is not even shown. But the backend knows, okay, I got an HTTP request with all of these settings, so I know a lot about the user, right? So that's arrow number 2. And we were tasked to build, so there was not kind of nothing existing, and we were building this platform. Okay, and out of that, we had to do like ID mapping in the sense, like this is pre-GDPR. So we were having like a same user came back like Monday or Tuesday or Wednesday. We need to know that it's the same user. We need to do a digest the article, so it's about football, the article that's being written. We need to understand that the user is interested in football. So for example, here, these are all the categories that a user could be interested in, and each category gets a score. That's a taxonomy attached to it. And then based on that, you would have clusters of users, which is saying, okay, these are auto lovers. These are there was in the big holding company, they also had like car selling website. So it would be interesting that when you read news articles about sports cars, then you are interested in cars, right? So it's cluster users. So that's what we were building as well. How we were building it now. Now, starting from the network layout. Our network layout was super simple. 3 environments isolated by account level. So these were different accounts. Yeah? So to do anything on prod, you had to first come to a prod account and do stuff there. So if you don't have access to production, you don't have access to production. You can't do anything. In terms of network layout, what we did was we had a VPC, so a virtual private cloud, set up for each environment. And each environment, we had 2 subnets, private, public. Super simple, right? Public, accessible from the internet. So please be careful when you open a port in this. Inside, don't worry, no one is going to come, right? Unless they jump over, and they first have to come to the private subnet and make it reachable. So kept the overall layout quite simple. So basically deciding when you are just putting a simple service that needs only internal API calls, you don't need to put it in the public subnet, you put it in the private subnet, right? It's very simple, and each account had its own key, and all the encryption was done with that key, so all the username and passwords were also in that account. So as you can see, like super simple, worked very well for us. And there are companies having multiple kind of structures. If you need it, if you have a justification for it, sure. But like for us, this was more than sufficient, right? Simplicity was the key for us. And then for each, so we had this catalog. So I take it back to the slide before where we were using Boise components. Now, it's like choice is much, much more. So for us, for compute, we were using containers, so Docker's running in the cloud, or we were using serverless. We were having queues, we were like highly scalable queues as Kafka, for example, or simple queue service. For storage, we were using different storage systems. Networking, we were also using some constructs. For infrastructure, we were using logging, security management, configuration management, and so on. But essentially, what I want to show with this slide is like you want to build, let's say, a little component. You decide where it belongs to. I want to make it reachable. Let's say you want to create a recommender engine, and that needs retraining or whatnot. You basically say, where does it belong? Which account? And then you say, which service does it kind of make sense? And you just roll up your sleeves and start doing stuff, right? Now getting the code deployed, that's also very important. That was also a setup that worked very well for us. Was like we had simple flow, which I think you must be already familiar with. The caveat here is that if you go back to the thing that I mentioned, so if you have you have a service, or you have your infrastructure as code, and you say, instead of 3 servers, now all of a sudden I need 2 servers. And that you should be able to specify in your infrastructure as code, right? That means you need to be able to spin down services. If you put 2 from 2 to 0, that means your service is down. So in theory, you should be able, and that's by design, you should be able to bring your service down, right? So now tracing back, if you are able to bring the service down, that's super powerful credentials stored in your version control system, right? So if you have that outside, then that's point of failure. So if an attacker wants to come to your production, the version control system is where you would attack. But with our setup, what we had was like we pulled the code to our environment. So we didn't have the powerful credentials for infrastructure as code in the version control system. Rather, we had it in our account, and the password for version control system would be in our account. Right? So we kind of flipped this problem. So with a pull approach, and to be able to do anything on prod, you first have to come to prod account. So that was actually quite useful for us. To now understand the news article, because I said there's an article, let's say on football, and then what we had was like very early on, with any external system that we were interfacing with, we tried to get the system to replicate it in the cloud. So for our case, we were getting the files as JSON dumped to an S3 bucket, but you could have anything. The message is, and there were quirks for that VPN. So the client had enforced that every day at 2 p.m., all the VPN connections would be reset. You can't build a reliable system like with such quirks. But the point, what we're doing is like we needed to replicate as early as possible here to the orange world. That would be like CloudWatt. From that point on, it's stable, and we can assume that things are going fine. And if there are quirks there, then a little adapter in the orange box would kind of handle that, right? So that the NLP engine can assume that there is a constant influx of edits to news articles, with which the data scientists were working with Jupyter notebooks. They were using blob stores for uploading the models. The models would be downloaded to the NLP engine, which was a Java application running in containers, and was saving thing on Elasticsearch. That was super nice, like made sense at that time, and we did not know. We're just thinking, okay, there's already Elasticsearch, let's put the data there. And we thought, okay, we're not spending so much money, let's just also put the news articles there. And turns out, like we just put it there, right? We are the data platform. We're not really delivering the news articles there to the users. But turns out the client was actually waiting for the service provider to spin up an Elasticsearch cluster to put the news articles onto Elasticsearch so that they could have a nice search. And we had it, right? So by commoditizing the infrastructure, we were actually better off at a lot of things. And we were not, again, doing things ourselves. We were a team of 4 engineers. I think mostly TUM graduates, actually. But good. Then the other thing which actually worked super well for us was like polyglot persistence. So what's the data? And this is a question that pops up again and again and again. What's the perfect database? We want to build a data warehouse. What we have learned is like doesn't really matter because like categorization is important, but what we had here set up. So users would click, and this GET request would be translated to like some JSON payloads would be coming eventually to a stream of events. Imagine again Kafka in the enriched stream. And we had 3 classes of storage. Like data temperature gets, like I think is the top term here. In terms of like, these are different classes of data stores with different limitations, different pros and cons. So for example, the data lake with S3 is like slow, but has the entire history of all the events ever. Data warehouse with Redshift, I think we had a couple of months data in Redshift and a couple of days worth of data in real time in Elasticsearch. So the data was piped to all of these data sources, and we had like a kind of sliding window on the retention of the data so that we don't spend up so much money on a certain data source. And when, let's say you are a data scientist, you want to get insights on the data, you ask yourself, how much data do I want to have? Because if you are really interested in like, short-term trends, probably you don't need like all the data in the world for the entire, since the beginning of time. You probably need maybe a couple of days worth of data. And if you need more data, you just store it yourself. Then comes to the new concept like data mesh. So we have, let's say, imagine like you have different microservices, and each microservices asks itself, what is the class of data I need to connect to? It has access to the raw stream, so it could get the raw stream, and it essentially picks, okay, makes sense, like I want to keep a pointer on aggregated data on the person's behavior, maybe that's the use case. That's the responsibility of this microservice to maintain and pick whichever database makes sense, right? And that's been thrown out for in the data world, data mesh, and again enabled by cloud, because then you just decide I need to try out RDS. You just pump in data, everything just works, right? And what we had was like each component was serving a particular purpose with the ID mapping. If you go back, as the stitching of the returning user, the ID of the returning user, that was like, let's say, a microservice, and again. With this blueprint, so it had an API where the authentication was not happening. So it's an internal service. So if you could come to an API, like the internal API, I don't need to additionally check that you have authentication because that was done with a central API layer. So you have like cascaded access control, right? And your internal API does not need to be public access to the internet. So a recommender system, for example, would have this blueprint. And has its own storage, right? So you don't need like an infrastructure level storage. So let's say we are building a user profile. So you have the filtered stream, which you get each click. Right? You have the possibility of storing each click. But you when we are building a component, well, do you want to store each click? Nah, maybe not. You want to probably aggregate them on the fly. So there's going to be real-time component, there's batch component. And for each real-time component, you pick the right tool, you pick the right metric, and then with the aggregated values, then you have maybe more, like a better chance on picking the technology. So for example, for this case, we were just aggregating. So if 5 users came to 10 pages and each user came 2 times on the page, then we would have 5 rows, right? And if there are like 2 pages, maybe there's like 7 because we also keep the track of how many views the content have. But essentially, you kind of aggregate and you don't need the raw data. And with that, problem becomes simpler. Okay, and for this case, we were using a key value store and also like the RDBMS. So we had to do lookups and we had to aggregate as well. So for this, we were using like DynamoDB as a key value store, think Mongo, and RDS, like think Postgres. So with that, we were building, like say, a user profile, what a user looks like. Recommender was similar, right? You get a hang of it, hopefully. So filtered stream, I'm getting all the streams possible. A user comes to the site. Then with that information, what I could do is like we were creating 3 recommenders. So first, I don't know about the user, let's say. I know everything about previous day because remember, we put the files in the S3 bucket. Based on that, I could say, if let's say all the things were down, I have a better likelihood of having a click if I send you most relevant news article for today, right? Than just random article. And that was like top performing articles. And this was something that the editors actually told us that they are recurring actually when you could also see it in the news sites these days. But top end performing articles are always like high performing. So for that, you don't need the funky recommender that we were building theoretically. But then you have another class of users who are, let's say, a little bit more mindful about what they read. So they are like, let's say, you need to give them like, okay, they read the popular articles. Like I read it, I know what there is top performing. I want to read a little bit more about, let's say, something is happening about TUM, then I'm interested about like education in Germany in general, and da 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 da. So I want to focus on the content. So content-based recommendation was another thing, and then another class of users were, now that doesn't cut it. We have to tailor it to the user. So again, a user comes to the site. We know that the user came to the site by attaching to the central stream, but we have everything in place in this little microservice so that we were using this information just as a signal, right? So we could have a high-performance recommender engine by translating and storing data. For example, we were using Redis. Redis is in-memory key value store. So when a user came to our site, the Redis did not make sense in the whole grand scheme of things. But for us, it was making sense because we needed to have a counter, have a really fast counter, for example, on how the user is, what the user is reading, what content is being read, and so on. And we use Redis for this, right? Okay. And again, API keys were which publisher was it and which user is coming. And based on that, we could already give, let's say, we have the cascaded system of failures as well. Again, blueprint is the same. Okay. Any questions till now? Okay. Good. So now so let's say we have taken apart two components. Now would be, let's say, a really big burning infrastructure questions, like how do you do monitoring and alerting in the cloud? And what we did was structured logging was very important. So it's in the responsibility of each little component, this little blue box, to say an error, right? To take it seriously. What is error for me in terms of logs? Like, so you can't just like go crazy with the logging and then you postpone the problem to an NLP problem on parsing the logs, but rather you're mindful about the way you log when you're creating the service. Then what you also do is you have to think about what is a relevant metric for you. For example, you are a recommender, right? And you are a component recommender, right? And then what you is a metric that is relevant for you is like number of recommendations that I have served. That's a metric that I know that is relevant for me. And if I get no recommendation for the whole day, that means something is wrong, right? So I decide the logs, I decide the metrics that is relevant for me, and I decide what is the threshold. That is, I think, making sense. So what we had, for example, was the number of fallback recommendations that were served. So that means the real-time system of the recommendation was not working, which, like, if you look at the system holistically, like, forget about it. Like, you have no chance of getting that. But then this problem goes back to the DevOps things. You are thinking about these things when you're writing your component, right? So the relevant metrics, the alert level is then pumped to the central system. And the central logging system, we said we are not able to manage this. So that is again a service, like just like the box of tomato sauce that we could get from the store. We didn't build a central logging system. We didn't build our Elasticsearch cluster and Kibana and so on. Like we didn't do this. And then what we did was we used the available components to actually just read the logs. Like remember, they are structured, so it's easy to kind of parse them. And when an alert situation happened, then we had a little Slack bot sending the alarm. Again, remember, if you are at the point where you are with this one, the cog wheel, and then you have to think, okay, fallback recommendation for 2 days, that's like, oh, that's maybe a failure scenario. I have to talk to devs, too late, right? So when you are a dev building this, you have to already think about it so that debugging becomes easier. And what we were also doing is correlation ID. This is an important concept for distributed systems. I think goes without saying because we were having event-based system, and each request to us had at the edge, we had a universally unique identifier generated, and that was kept throughout the system. Was super valuable for us for reproducibility, for traceability as well, right? So when a user came requesting a content, he or she had a page view. Correlation ID was generated, and that was kept throughout the system. And another thing is like monitor all the, this is the log that we were seeing as well. So, and this was like a pattern that we see, that we saw all the time, like the users, and this was, you could see that, yeah, people are coming to the news article during lunchtime, and at night, of course, no one is reading the articles, right? And what we did was like, we had this in the big dashboards, and then every metrics that we got was kind of correlating to this. So if we were observing, let's say the throughput of, not throughput, but let's say the load on our stream, same pattern, right? The load on our database systems, kind of same pattern. And then this gave us, on one hand, like we were just monitoring everything to see, okay, makes sense, I can reason about it. Or it says, wait, that doesn't really work. So maybe we could kind of optimize on the type of storage, for example, and so on. But we were like monitoring all the things and gladly paying for this. Log all the things as well. So trace level and being mindful about what you logged was really, 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 really crucial for us. And then we were logging it, and by and even the log was actually the log. Like was the number of log messages was actually somehow following this trend as well. So systems are working, systems are kind of spitting out the log messages. So if you just count the number of logs, that was also somehow correlated to the peaks that I showed you earlier. And the benefit now comes of the cloud is that you can scale things on demand. So if you see the peak, that is the load on the key value storage of our system, and we had auto scaling in place. So if we over provisioned, then we would be paying $1,400 a month. But we had because again, going back to monitors, we don't need that much provision overnight, and we need to really provision during these peaks so that, for example, recommendations can be served. And and this is a point in time when when Amazon folks did not have these auto scaling built in place. So they did not have auto scaling, but you could set limits. Yeah, you could set the provision limit. What we were doing is kind of auto scaling in house because we saw a bit of value in that. So we were essentially setting the maximum capacity for the service that we were using. Just that, right? The rest of the auto scaling, the fancy load balancing, all the stuff was done by them. But we knew that our traffic was predictable because we had monitored them. We had monitored how the load was over time. Like this was, as you can see, this is a repeating pattern. So what we were doing is we were provisioning capacity on a scheduled fashion, which saved us a little bit more money. So what did we build? We had over 200 serverless functions. We had conventions to have auto generation and introspection of architectures because we were using this blueprint. So all of the component, just pick one. You could go to a GitHub repo for that, and then you can kind of navigate already. And cost attribution of also a component was possible because of tagging. Because now imagine that you are, let's say, a developer, you have the hat of building a recommender engine or one component of recommender engine. You can pick any database that you want, but now let's say you are getting billed at the end of the day and you want to know, maybe that was not a good choice. You need to be able to kind of trace back your steps. So what was also the responsibility of us as we were developing the code was tagging was super important. So that we could say we could even say, how much is a recommender costing us? These are the questions that we could actually ask and get the answers to. And then we say, is it even worth optimizing, right? So we were measuring it and then asking ourselves, is this if we are spending a lot of money on recommender engine and more money, let's say, on just the storage, we then know where we need to optimize, right? And that makes our life simple and also gives us the flexibility of not having to make the call of for example, which database type. Do I need to really pick the version of MySQL on the server because that has this little optimization objective? No, just pick another. because for our case, like by just switching technology, right, was more than sufficient and did not justify the additional cost that would have required for you to do these fine tunings. Now, debugging. So we had everything with CloudWatch. We had the centralized logging. We were analyzing metrics, and what we could do, this is essentially the same picture that I had earlier, but just reversed, right? So you get an alarm. From the alarm, you see each component developer, remember that hat was worn, and then he was tagging, I am a recommender metric. So okay, that component. Then the component has a repository. The repository has like a chain set, has a feature branch, going back, and the feature branch has a tag to a Jira ticket. Okay, because we introduced a new recommender type, that's why everything is going slowly, and maybe causing an alarm in our Slack, right? So debugging this tracing of things becomes very easy, and not solving it at the cloud, but rather taking ourselves back and making ourselves responsible and mindful on the things that we are doing. So on some statistics, right? What we built was like 300 NLP processed per day. These are edits also, right? So when an editor is actually typing a newspaper article about, let's say, football as things are going on, that comes as a new news article to us. So it's like a lot of news articles being digested by the system, and 4 million NLP process content overall. That's like entire Blick.ch. And 35 million tracking events per day, 50 gigabyte of tracking events per day. This is the the incremental storage, and I think the numbers might have increased. And real-time output of 10 seconds from when we see the first user. Google Analytics needs 2 hours. Just to put things into perspective. Of course, we are not Google and the volume is not there. The problems are different, of course. But with Google Analytics, the client had the problem like it's just too long. The things are happening too quickly. So for us, like we could manage with a lot of frills out of the way. And again, this is not comparable with Google Analytics, but just the numbers in the sense like it was 10 seconds until you come to a page and you come to a page about football. And the system knows that you are interested in football, right? And 7 seconds, because we were also calling external systems until the article was understood, right? So that's the NLP part was 7 seconds, but once the article was understood, then 10 seconds until an interest profile was built. And that was, we were using a multi-arm bandit, so the recommendation engine was constantly learning. So we ended up creating 6 million interest profiles a day. Now take that in the whole population of Switzerland, so configurable population of Switzerland that we were able to get an insight of throughout the day. And again, as I showed you throughout, building blocks, kind of the same, and you can arrive to so much by not thinking so much about optimization and by thinking just about productivity and let the cloud provider do the important things for you. And when it comes to a point, again, driven by metrics and monitoring, like now it's time to optimize, and then you optimize, not the other way around, right? So support is also a very important question, like because one of the requirements was 24/7 support. But we're a team of 4 engineers, right? Working with NetLight, we have our lives, and we can't be there 24/7. But then we got a service provider, and what the answer that we got from them was, I can restart a server, but wait, you don't have servers because we're doing serverless, right? What button do you actually press? So we ended up creating runbooks for them. So at the end, the setup was, we have SLA of 2 days to fix because of the weekends, and one of us would be there from the team. And remember that we got an alarm on a Slack message that a team member who created the code could understand, right? So realistically, 2 days. And then shorter response time for acknowledgement, because that was apparently sufficient and that was a good middle ground. So the service provider, which actually was used to shutting off machines and restarting them, said, we acknowledge, which arguably could be automated, but they acknowledged, okay, problem is there, someone is going to take care of it later. And then one of us came, like let's say Monday morning, and then we see what it is, and then we provide an estimate, and then we solve it, right? And a point here is like, it can probably be done, right? But as a small to medium business, you should not expect to have better SLAs than the underlying cloud provider. I mean, can be done, right? Like we know that more robust system can be built on top of like unreliable systems. Like that's what all the smarts of computer science kind of goes into, most of them, anyways. But then, as a business on the cloud, the first problem that you would have to probably live by is that the SLAs can't be better, right? And then you start with an assumption, go forward, and then when you hit to a point, again, driven by metrics, and then you fight that battle. And cloud providers already have very good customer support. We had someone working for a cloud provider actually in the room. They would probably stand by it. I mean, they are also, like graduates like us from good universities, have a lot of experience, and are focusing on a problem. And these are also people behind the scenes, and and they are also super eager and helpful as well. So let them handle it is the thing that we have come to realize, and we have been talking a lot with like AWS support people, and then they also have levels of like contact, and you don't really get to the people who are actually doing the algorithms and so on, but you could, if that's the problem for you. It's much easier than people think to actually get to the people, and they would be excited, and you'd be, without realizing, you'd be joining the same meetups as them, right? So, a quick run through of the lessons learned. So, which cloud provider you pick does not matter. That's the lesson that we learned. Just make your pick, move ahead, hit the problem, and then you evaluate, because already at the super high abstraction level, you can be so much productive and you can make so much business. Jump in, try out instead of falling into trap of analysis paralysis. That's follow up to the first point. There's no silver bullet on the database storage technology for all use cases, right? Just pick make peace with what are the categories of the data source you have. Each one has its own like pros, cons. Think about data temperature, think about data mesh, and there's value in just picking a class of database storages and flying. Use managed services wherever possible. Again, don't go back to your own Riviera. If you want, you have a really good reason for it. Sure, if you have a really a customer coming to your house and he's really a pizza connoisseur and he would differentiate and he would not eat the pizza from a tomato sauce bought from supermarket. Of course, that justifies it. But otherwise, if your goal is to reach a lot of users, use managed services. Infrastructure should support introspection with minimal documentation, and that's also something I think very relevant that I would have asked like older version of Saksham to try to do more of. It's a little bit counterintuitive, but force yourself to write as less documentation as possible, right? Again, a thought experiment, but if there is a documentation that you have to say, please do this, or like you have to ask yourself, are you actually nudging towards creating a character for this little component? Because arguably that could be created as infrastructure as code. The things become reproducible. And we were going to really extreme lengths there. Naming and tagging conventions are essential to minimize complexity. Like this is very, very important. It might think like, come on, you're arguing over name. It makes sense, right? Otherwise, just remember you'd be debugging, you'd be firefighting, and you don't want to even think about these things then. Automate everything. Clear. Split environments. Environment for trying things out is worth the cost. We were, at times, for some of the services, we were paying 3 times. As you remember, 3 environments, right? 3 times cost for some services. Was worth the cost, was in thousands, but completely worth it. Because what it gave was us the confidence, because if you now can go into DevBox, you break everything. Like the dev account is empty on AWS, let's say. So what? You learned that you should not do that. That way, you have additional confidence for breaking apart, because you still have int environment to take your infrastructure as code, you still have prod environment which you should hopefully not break. But the code then is tested on the int environment. So just for this flexibility of trying things out, that was kind of worth it, right? Personnel cost is much higher than infrastructure cost. And this is something, again, this is very important that I would have liked myself to know. Test your infrastructure as code by tearing down environments, because then you get disaster recovery planning for free. Because what we were having is like every now and then we would just delete the dev environment. Yeah, just delete, like we would do it usually before the holiday. We tried it the first time by before the holiday season, so that the devs would not have like problems, like devs as us. But this is very important, to be able to have the courage to tier your environment completely, because then things like these quirks, these manual steps would pop up, and then you know what to automate. And by us being in these three environments, that was already kind of remedied. Okay, that's kind of it, I think, what I wanted to share with you. So that's me, that's Michi, and we have an event. Maybe you want to tell a couple of things?
Saksham will have like little talks, at our rooftop summit. The next event is the 9th of August. If someone is interested, feel free to join.
Yeah.
But I guess right now is also the perfect chance, also after this talk to us.
Yes. And then I can't believe that we don't have questions. So I'll put the slides up, and happy to jump into any questions that you have. Very good question. So the question was how, like, we built AWS services. The question was precisely, and correct me if I'm wrong, how did we develop things? Because then you would want to do some things locally as well. So for us, I think there are a lot of tooling available these days, so that you could have some services replicated of course, in a smaller scale in your local computer as well. There is I forget the name of the library, but there's something that replicates, for example, queues, some things that replicate like buckets in your local computer. What worked for us was we tried to containerize everything, and we had these really interfaces where we had, for each component, we had also a Docker Compose. Yeah? So what we knew was okay, there would be an incoming event, and the liberty that we had was our system was an event-driven system, right? So we had this incoming flow of events adjacent in to our system. The system is kind of self-contained, so we had containers at the level of a component, so the recommender system. We had Docker Compose up for having the recommender, spinning up the a little, I forget which database we used, but Redis, local Redis, local kind of containers with scheduler and so on, for a recommender, which had an API endpoint which we could send in the user ID and the tenant ID. Yeah, so we had that. Then now on the level of each recommender, so this was like a Flask API that we were Fast API that we were using, and that was also a container as well. So we were as much as possible trying to use containers, finding the endpoints so that you know what you are testing. Right? So for Lambdas, for example, these are the serverless functions. The code, again, they are triggered by events. So they would be invocable also. If you looked at our Lambdas, they would be also invocable locally. We actually spin them up into, we were using Poetry for Python functions, and they could be invoked running locally, and they could accept a JSON. So what we would do is actually, when a problem arrives for a long time, we actually have the event saved, and we would use these JSONs and replay them locally, trying to kind of debug our code. Yeah. But containerization, I think that's as much as possible. Yes, you could say that, yeah. So we were taking, each component had its own repo. That was the, so we were using, this was, again, I feel old. This is pre-CDK. So we were using Ansible with CloudFormation. But essentially, imagine that you are generating YAML for CloudFormation with a bit of Python. That's essentially CDK. I mean, TypeScript, but you get the point. And each little blue box was a repo on its own, with its own infrastructure as code, with potentially its own release. Yeah. So, and that, like, I think it's maybe a good picture comparison would be one Docker Compose, one component, one CDK, and one repo. So you could say Docker Compose recommender component up had already an API endpoint. Again, not doing authentication, right? So this is an internal component, which is like JSON in, JSON out, authentication out of its responsibility. That simplifies, again, a lot of things running locally, because then we were using Cognito. Otherwise, we'd have to kind of replicate also authentication. Yeah.
You mentioned before that this thing was designed before GDPR, but so how did it change with the GDPR?
Yeah, very also like yeah, that was a really important question at that time as well. So the question again is, GDPR, like I described that this is at the time when GDPR was introduced. How did it affect us? Did I get that correctly? Actually, what we did was, like, because of the structure that we had all the content and everything, including the model that is generated using a content keyed by content ID. Remember, like two sources, right? So one is content, one is user generated. So user clicks, user. And the other side was that if anything is coming from a user, then has to have a user ID associated, even when we match the IDs of user, right? So we can always go back to the cookie ID that generated the insight. So let's say you have a profile and this is just a dot in the cluster. We know which user ID it came from. And GDPR, like one of the requirement was, well, you have to be able to switch it off. That's the first thing, right? So, and we had we were already thinking in the terms of, like, now all the websites ask for like zustimmen or ablehnen, or that's a word that I learned from German. Like, you have to consciously accept, and when you accept, then it starts tracking. That's one thing that we had to kind of introduce in the tracker. And the other one was be able to delete all the messages or data that is stored for you. And it actually was really helpful for us to kind of also do this exercise, because we wanted to make sure all the components would have the data correlated with the user ID, and we were able to delete it. So we had to kind of create a little bit of scaffold around it for data retention policies, and this possibility of being able to delete the data when the user requests for it. But no fundamental change. So everything was kind of around it. Yeah. Hopefully that somehow gives you a picture. Yeah.
So you did not mention it once, the cost of deploying it in the cloud. Was this not important to your customer, or did you take this into account when taking architectural decisions?
Yes. Yeah. So the cost of running it in the cloud or developing in the cloud?
No, running.
Okay, that was just part of the operating cost. That we just made peace with it. So the bill was 35,000 a month for production environment, and for other environment was like 15, and the dev was like, I think, a little bit less. But then that would just factor in as a cost, because what was very important, and this is a question that we were asking, and that has been also like that we have been asking ourselves on the design decision, for example, because if it's too much, that should justify us to look into optimization. And the perspective that we were that was driving us was like we were external company. We were not involved in the media company. So we are like, let's say, an external company. What is the value that we could, if we could customize, do these little optimization, then we would have to kind of document. We'd be probably building our own tool, and the likelihood of a new person, like or the ease for the person to just a new person to come to the project and just learn something that we have built in-house, compare that with something that we have been taking off the shelf, right? And that's somehow always made sense for us to just take it as a running cost. And if it just became like too much, like or we got a spike, that could not be attributed to an increase in the volume of traffic, then we actually took a deeper look. And like we had this low burner where we tried to bring this down a little bit, like by swapping database types and by tweaking, for example. For example, Redshift was a cost driver, Elasticsearch was a cost driver. By just changing the window of retention period on Redshift, we could actually save cost. But that was always a conversation. We could always do that. We always have that lever when that becomes a problem. But from our experience, like 35,000 was, again, the bill. And then the data scientists also, like that is also an important perspective. Like let's say we save cost, we bring the cost to 20,000 instead of 35,000 per month. But if the data scientist who's used to getting the data from Redshift now expects the data now from S3 bucket, and you have to build the tooling, and then, yeah, you're back to. So you have to think about the problem a little bit holistically. And maybe to the same topic, what was also important, and was the question that I raised earlier on the serverless. I don't know if you remember, but then if you use like cloud functions, GCP functions, Azure functions, AWS Lambdas, the cost goes linearly, right? And for some components, I wish I could draw, but you know you have to make do with my hand waving. So the cost goes linearly for let's say you use serverless function, and for some it makes sense because you know like it just makes sense because the initial it starts very low, like for millions of invocation you just pay like peanuts, right? And then after a time though, like then you have this, if you were using, let's say, virtual machines, maybe containers, Kubernetes, and so on, there's a little bit of upfront cost, but then it plateaus over time. It does not scale linearly on the number of invocations. So it, you know, plateaus after a certain time. So there's a crossing point where per on-demand invocation just becomes too expensive. And that was the case for us for our collector. So if you remember the picture, so each event, when a user viewed a page, that was not necessarily causing us more, like creating more revenue for us, but was causing more cost for us. And for those cases, the cost conversation was important. And what we ended up doing was like we containerized it. So we took the problem beyond the Lambda invocation. So we were going back from serverless to a containerized application, but just for a collector, right? And again, maybe coming back to your question earlier, it has to be treated as a running cost at one point. Yeah.
I feel like all the tooling in the cloud world is quite young, quite novel. For example, like OpenTelemetry probably wasn't a thing when you started. Did you have to build like all the monitoring
Many.
systems?
Many things we had to build. As you were saying, right? CDK. CDK was not there, and there was a creative way of using Ansible for us because CloudFormation was not cutting it because we wanted a little bit of dynamism in the templates that we create, and for that, dynamic CloudFormation was not there, which is essentially CDK. So we had to use Ansible for creating like CloudFormation. Fortunately, none of them infrastructure level, which also like I wanted to show from the picture below, like above, logging was there. If that was not there, then yeah, we would have to invent a lot of things. Yeah. Yeah.
As a company, you provide the development of the service and then you also provide some maintenance, or
Yeah.
how does this work?
So maybe let me take the question. So the question again was how do you provide like service and how do you operate and difference between development and maybe maintenance, operation, and so on, right? Did I get somehow?
It's just like what does your company provide
Yeah.
to the customers?
Yeah. Okay. So for this use case, what was there was like again, don't quote me on the year, but it came as the head of data, trying to build this platform on the cloud in 3 months, or was it shorter, right? So just as an Excel sheet, I don't know how. Please help me build this thing. And then we were with this project for 2 years, trying to build it, and always have the. And so we developed it, we conceptualized it, we presented about it, we were operating it as well, like as I said, like 2 days of SLA, right? So we were kind of operating it as well, but not providing 24/7 support because that would have been like that would not have worked out with maintaining a team of, let's say, engineers who are able to build in the cloud on 24/7 support. That's very expensive for the companies. So operation, yes. Async monitoring and debugging, yes. And at the point of when the support came, then we were very keen on the media company to just find a partner who could take over and take the daily operation. Right? So building and operating it and make it ready for further development. Let's put it this way.
Was the question based on this project or NetLetters in general?
Yeah, that's also maybe.
Maybe more general. Like
Yeah,
you
yeah,
have like
yeah.
4 customers, so
Yeah.
you take one customer at a time, then you operate this one, and you already develop
Right.
others.
Okay. So generally on like maybe a NetLight as a consulting company, and at which stage does it come? And it's all over. So there are projects. So this is a typical project, which I think. There are some greenfield projects as well, which this was the case, but there are also customers coming and saying, okay, the bill is too big. That actually also a question. The bill is just too big. Can you actually help make sense of it if it's worth investigating? And so you have to kind of look at an operating system, look at kind of all the things going on, but only maintaining a system. That's not something that we do. So it's usually starting always with a problem that the client has and comes kind of to us. It's again goes back maybe at the infancy of an idea in an Excel sheet. So we maybe make sense for the product engineers amongst us to actually collaborate with the client. Or it's like a scalability question, a performance question, where a little bit, like super experienced engineers would be into the project. But let's put it this way: like it always starts with a really problem that the client is facing, and not really operating a running system, right? And oftentimes it's also tied to growth. So like a new country where they have not really tried out, so they want to launch a product in a new country, and they don't know where to start. Right? That's also another case where we help the client.
Basically, it's hands-on software
Yeah.
appearing in all types of ways.
Yeah.
There's no
Yeah. So.
specific technology or industry.
Right. It's exactly so for the data platform case that we helped with. So this was a team of 4 NetLights, and we all are informatics masters graduate as well, like yourselves, like very soon. And then whatever needs to be done, we're like rolling up our sleeves and doing it, and hands-on problem solving. Right? That's what we pride ourselves on as well.
But then you split actually DevOps again into development and operation.
Yeah.
That's software over to
Yeah.
the
Yeah.
Swiss
Yeah.
company
Yeah.
there,
Yeah.
that they run it.
Yeah. So the idea is like that's a hat. Like at least what we try to do as much as possible is like we try to put the hat on our heads, like the dev hat and ops hat, and we just show hopefully how it's done. So it's like less like amount of time if you just put it on. The amount of time that you put your dev hat on that decreases over time, but we still facilitate people to take the hats when it comes by making the process very simple. By easing debugging, by easing tracing, and also facilitating development workflow so that the releases happen very quickly. So you essentially, make it simpler to wear the hats.
Is this a general approach when you think about taking something to the cloud? So
Yeah.
other companies
Yeah.
that actually say sort of do the initial implementation and make it easy to continue the development, bug fixing, operating it, and then you hand it over to the customer and he basically has to manage that by himself? Or is it like that also companies get the responsibility for the software
Yeah.
for longer term?
Yeah. So for most of the cases, it's more on the product level that more opportunities open up. So the team actually ends up growing, enabled by cloud. So as I said, like I'm at the insurance company, and we are just looking at the BI platform and trying to move from an on-premise system, which is in Paris, I think, to cloud. And it's a small team, really big department. So there's like a lot of things to do. So even moving this over to cloud, it's a lot of challenges. But the goal is essentially the same, to make the client self-sustained in a way, so that they can take care of things themselves, and we move out of the way.
So there's not the danger that the people at the company would actually fear that you
Yeah.
take their job, but
Right.
it's more like taking them to a new level.
Exactly. And that's also like going back to what I mentioned as during introduction, like as we want to help people to like organizationally to move to cloud. It's not about like taking because it needs training, and if the people can just do themselves, like build themselves this, we just move out of the way. Yeah. More questions? Yeah. So the question is around how do you handle you're handling data about customer? How do you handle security and trust? So these are, maybe I split it out. First, security. As I said, like model is very simple. All the data is encrypted. The key is there in the account. You have access to the account. You can see the data. Framed with GDPR compliance, right? That's one thing. So data on rest, data in transit, encrypted with normal encryption mechanisms, right? That's security. But you secure your key. We don't go to lengths of doing additional security, like if the algorithm is compromised, just secure your key. We trust AWS to do its decent job on securing the things. On the privacy, now this is again, the account is owned by the client, so Netlight does not own the account. So we are actually approved to be in the account, right? So it goes with general approval process. Like as we get a laptop, let's say from TUM, you are already having certain framework for you to, be responsible about the uses of the data. So Netlight does not own the data, right? And Netlight is rather help setting up the client, whatever needs to be set up, and we kind of dog food, and we just give access to ourselves because the project needs it. So that's the kind of the level. And when the point arrives, let's say there's no trust, so you don't get access to the data. So for example, when you leave the project, you don't need the access. You just are off, right? You can't use the data. So that would be, let's say, trust question. So that we don't store the data. The client stores the data and grants us the permission. Yeah, and maybe piggybacking to that question, and oftentimes some clients think about, but what about AWS? What about NSA? Don't they get access to the data? And oftentimes the argument is valid, but the alternative would be so we had a customer who was having all of the source code, all of the data in a server at the office. Okay? You don't need to be a hacker to break down HTTPS protocol, attack, show up at the office. You have access to data. Right? That was actually an approach used by one of the, I think in HackerCon conferences, one of the teams actually bought a hard hat, went to the server room, pretended to be construction workers and sneaked into the room, the server room, and then they got access. I think there are companies who have much bigger stakes than a small company, and even that's applicable also for a big insurance company here in Munich. So most of the cases, I think that's why you pay so much money to these big names, and then. In terms of governmental agencies and so on having access, they have they have big clients which are already supported. So if you have requirements like that, what they offer is then the data stays in EU, for example. That's not then American regulations don't sneak into the data. Yeah. Hopefully, and so far, that has somehow worked out in terms of both trust and security, in terms of the projects that we have worked with.
But there must be a way of establishing trust.
Yeah.
As you mentioned,
Yeah.
so you get a
Yes. Well, yeah. Yeah. Yes. 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 Yes.
probably say this goes over several rounds.
Yeah.
And
Yeah.
you more and more access to information
Yeah.
inside of BMW.
Yes.
And the major means probably to make it guarantee, is probably that you have to sign contracts and with significant fines, I would
Yeah. Absolutely. Absolutely. Yeah. And it goes all the way to there were some banks that we worked with, and it goes all the way to HSM, so hardware security modules, that you could install on these data centers. So if you don't trust the data center, right, that is maybe the level of, or the foundation for the trust system that you want to build. They provide flexibility even for those. And I don't know if you have, maybe someone had worked in a data center, maybe they know, but HSM handling is that's another league. They are not even allowed to use the same channel. So, and even at that level, they support establishment of trust, so that you would have your own HSM. Of course, that takes a lot of responsibility on you as an organization, because if the data becomes corrupt, they can't help you, right? And then you have to have. So, for example, for the insurance company, there is an offering that we could use our own key. Didn't make sense for the insurance company because they don't have the infrastructure in place to secure this key, right? And we said, okay, we make do with the audit trails for the key. Key stays still in Amazon. It's audited and so on. And then we just make peace with it, and we can't afford to have our own, even like a private key. But they provide at hardware level of SSM level of establishment of trust, because then if companies like a bigger insurance company does not trust themselves with let's say a security like a software-based security, for hardware, more things can go wrong. So maybe as a university, potentially that is an infrastructure that you could afford, but as a company, maybe not.